This is just a close-up view of the x-axis end stop here. You can see this one's a little bit different because it's an optical gate. When the x-axis comes home, it blocks the little hole, and that's how it knows that it's at home. You can see that it has a bit of over travel, and so what it does is that it calculates the maximum velocity that can move the x-axis in the home direction, and once it blocks the LED light, it starts decelerating, and it calculates the maximum velocity that it can travel without crashing into the end here. So I can go ahead and show you that if I run the homing routine. I'll get up a little closer here. It does that for the other axes as well, but the optical one is a little bit nicer. Here's the y-axis end stop. You can see it's just a little micro switch that it actually hits this little chunk of metal right here. It fits underneath nicely. And the same thing, there's a little bit of over travel. So if I go ahead and run the y-axis homing routine, let's see if I get it to focus, you should be able to see that. Alright, so I got all three axes working at the same time, moving a specified distance at a certain speed, and I've included accelerations. So here I can show you a demo of that. I'm working now on getting the motion of the four axes synchronized so that the printhead always moves in a straight line, no matter where it's traveling. And that explains the lines here on the paper. I've been just holding a pen like that to get it to plot a line so that I can see it visually. But if I run a test here, you can see it. So you can see all the axes accelerate and decelerate all in sync so that the linear motion of the printhead is completely synchronized.